Hello again, guys. Welcome to 14.5 conditions for rhombuses, rectangles, and squares. So our essential understanding here is we can determine the special type of a parallelogram based off of properties of its diagonals. So how do we do that? We apply what we learned in last lesson. So Theorem 53 here starts off by essentially the inverse of what we know. What we knew before was if we had a rhombus, its diagonals make a right angle. Now what we're going to do is say if in a parallelogram, so we see AD parallel to BC, AB parallel to CD, if I see that the diagonals meet in a right angle, then that tells me that ABCD is a rhombus. Here's the proof of that. If you'd like to look at it, it makes complete sense, so I'm not going to spend a lot of time going through it. Theorem 54 applies the other special property that we know about rhombuses, where the diagonal is actually an angle bisector. So what we see is we have a diagonal drawn here. It bisects angle B into angles 1 and 2, which are congruent because it's a bisector, and it bisects angle D into congruent angles 3 and 4. This tells me that ABCD must be a rhombus. So now Theorem 55 talks about our special property of rectangles. If I have a parallelogram, again we see the parallel opposite sides. If I have a parallelogram where I can find its diagonals to be congruent to each other, then I know that this parallelogram is a rectangle. So before you try the got it, please make sure you've worked through the first part of the Pearson module to get to this got it, and then pause the video and try it on your own before coming back to get help. So when we look at number A, it's telling me a parallelogram has the angle measures of 20, 160, 20, and 160. Then it asks if it's a rhombus, rectangle, or square. Well, hopefully you quickly identify it's not a square and it's not a rectangle because it does not have 90-degree angles. Now that brings us to asking ourselves, is it a rhombus? Well, it could be a rhombus, assuming that it satisfies all the other classifications where all four lengths are congruent to each other. And we already know it is a parallelogram, so assuming that it has four lengths that are congruent, then it would have all the properties needed to be a rhombus because the opposite angles are congruent. In B, we're told that the diagonals of a quadrilateral bisect each other. So can we conclude that it's a rhombus, rectangle, or square? Now, if we think about a quadrilateral with diagonals that bisect each other, all that classifies is that it is a parallelogram. So we can't conclude that it's a rhombus, rectangle, or square, but all we know is that it is a parallelogram. So there are your answers for A and B. When we go and look at our practice problems 1 and 2, go ahead, pause the video and see if you can figure out whether now be as specific as possible if we have a rhombus, rectangle, or square. Alright, so when we start looking at these, when I look at number 1, the first thing I see is that based on these markings down here and up there, we see that our angles have been bisected, and since we know that this is a parallelogram, then we can say that this must be a rhombus because our opposite angles have been bisected. Now when I look at number 2, I see my diagonals bisect each other, and that's good because we know it's a parallelogram, but the diagonals of any parallelogram bisect each other. What you are thinking is that this would be a rectangle, but we're not told anything about any of the angles, and we're not told anything about whether the diagonals are equal to each other or not. So we actually cannot determine what type of shape it is aside from knowing that it's a parallelogram. Alright, so make sure you work through the Pearson module to make it to this got it. We see that we have a rectangle here, DEFG, and we want to figure out what the value is for y. So think to yourself, what do we know about the diagonals of a rectangle and how can that help me? So pause the video, solve this out, and come back to check your answer. Alright, so when thinking about a rectangle, we know that a rectangle is a parallelogram, and in a parallelogram, the diagonals are going to bisect each other. But also in a rectangle, we know that our diagonals are equal, so since the diagonals begin as equal, when they're bisected, the sections of the diagonals will also be equal. So I can start by saying that my 5y plus 3 is going to be equal to my 7y minus 5. From there, I subtract 5y from both sides just because I like keeping my variable value positive. I then add 5 to both sides. So I get 8 is equal to 2y, and then I divide by 2 to find my final value of y to be 4. Go ahead and pause the video to try numbers 3 and 4 on your own, knowing that these shapes down here are special parallelograms given to us as a rhombus and a rectangle. So if you're struggling to figure this out, what you need to remember about the rhombus is that our diagonals always bisect the angles, and in a rectangle, our diagonals are always congruent to each other. So when we start number 3, I can set up the equation that my 6x minus 9 angle would be equal to my 2x plus 39 angle, and then I can say 4x minus y because I subtracted 2x from both sides. Then I add 9 to both sides, and then to get rid of the coefficient of 4, I just divide by 4, finding that my value of x is 12. For my rectangle here, because my diagonals are congruent and ln is a diagonal and mo is a diagonal, I know these two binomial expressions will be equivalent to each other. So I set up our equation, then I subtract 2x from both sides, I add 7 to both sides, and then I divide by 2 to find my final answer of x being equal to 10. Please make sure you work through problem 3 before trying this problem because it will not make much sense if you have not worked through it yet. So in problem 3, they're trying to build a rectangular area that they can use just by using the diagonals. So you end up at the end of problem 3 with something like this where they've used the diagonals, stretched them out, and they can find that since these diagonals are congruent, that they must have made a rectangle. Now, when we want to make a square play area, you should remember that a square is nothing more than a rectangle that is also a rhombus. So I need it to be a rectangle, so I need my diagonals to be congruent, so these two sides are congruent until I goof it up, so I need to go back and lock that. So I went ahead and gave some color to my diagonals, but if I run my diagonals, attach them in the very center of them, so I know that my segments are equal, so that I have a rectangle, but then I line up my diagonals so they meet at a 90-degree angle so that they have a perpendicular intersection, then I will know that it is a square because when my diagonals are perpendicular, it makes it a rhombus, and when my diagonals are equal, it makes it a rectangle, and a rectangle that is a rhombus is a square. So number 5, we're looking at a carpenter building a bookcase and how we could use a tape measure to check that the bookshelf is rectangular. So I just grabbed an image of a bookshelf off the internet, but I want to say, how do I know that this is rectangular and perfectly rectangular, that it has been built correctly? So pause the video, think about this for a second. Think about writing out your solution like if this was a standardized test, what properties we would use, what do you know about rectangles that we could check here to make sure that it is a true rectangle? And our answer is if he measured from the top left to the bottom right and got your diagonal, and then measured from the bottom left to the top right and got your diagonal, as long as those diagonals are congruent measurements, we know that it is a rectangle. If we want to go even more detailed, we would want to measure the top and bottom first to make sure they're congruent, the left and right first to make sure that they're congruent so that we know that it's a parallelogram. And then we could make sure that the diagonals are congruent to fully verify our rectangle. 6 and 7 should not take you very long, so pause the video and write down what specific name for the shape is best. So we see here in 6 that it gives me SO congruent to TP, and when I have diagonals that are congruent, I know that it is a rectangle. In 7, I see that my diagonals have met at a 90-degree angle, and when my diagonals are perpendicular, I know that what we have is a rhombus. Go ahead, try 8 and 9 on your own and come back when you are ready with your answers. Alright, the first thing we want to think about in a rhombus is to be a rhombus, all sides must be congruent. So, therefore, I can take the two sides that I've been given, set them equal to each other. I can subtract 3x from both sides, add 1 to both sides, and find out that my value of x is 2. Now for 9, we have a rectangle, and what I know about rectangles is the diagonals are congruent as well as the pieces of the diagonals. So this small section down here is congruent to this small section right here. So I set up the equation. I subtract x from both sides. I then add 5 to both sides. And then I divide by 2 to get my answer of x being equal to 3. That is all that I have for you guys in this lesson, so please make sure everything makes sense. Let me know if you're having any issues, and I will see you guys in class. Have a terrific day.